Okay, today we will see how to solve the Fourier transform of f of x. Okay, so this Fourier transform of f of x is given by, we are just going to see the solution alone. Okay, what do we know here is, we know that the Fourier transform of f of x, the Fourier transform of f of x is equal to integral over minus infinity, okay, integral over minus infinity to plus infinity f of x e power j sx dx. This is what we have, the Fourier transform of f of x. If you notice, there is a presence of, what does that mean? F of x. Okay, so I need to substitute this value f of x. Before seeing that, how is this f of x defined? Okay, let me go back to my f of x in this question. My f of x is equal to 2 minus modulus of x. If you notice here, what do we have? 2 minus modulus of x when mod x less than or equal to 2. And it is equal to 0 if mod x is more than 2. Okay. So what is it you are given here is, in general, your f of x is equal to 2 minus modulus of x mod x less than or equal to 2. Elsewhere it is 0. Okay, 0 into anything is going to be 0, so don't need to bother. What do you mean by modulus of x less than or equal to 2? It is nothing but minus 2 less than or equal to x less than or equal to plus 2. The meaning of, I am just telling, modulus of x less than or equal to 2. So what it happens here is, I can substitute this f of x equal to 2 minus modulus of x when the limit of this one changes from minus infinity to, minus 2 to plus 2. Because elsewhere my f of x is 0. So my f of x is defined only between minus 2, that is non-zero value. Okay, non-zero value, what is it? 2 minus modulus of x when minus 2 to plus 2. Okay, so let me remove this and then we will go on to the substitution. Okay, so when I substitute my f of x, okay, let me rub this again fully. So what it happens here is, when I saw the definition of f of x, it happens to be, it is defined only in the place minus 2 to plus 2. Okay, 2 minus modulus of x. In all other places, it is equal to 0. So I have substituted my f of x value. Okay, in all other places means minus infinity to minus 2 and 2 to infinity, it is equal to 0. Elsewhere, it is equal to 0. Okay, I have substituted. Now e power j sx. E power j theta, my students would have known that e power j theta is cos theta plus j sin theta. Okay. So what are we having here is, if you notice very carefully, I need e power j sx. So instead of theta, sx I have. It is cos of sx plus j sin sx. Okay, like this we have. So now this can be, instead of this, I am going to substitute here. It is, what is it I am going to substitute here is, it is cos sx plus j sin sx dx. Okay. Let me remove this. This is not required. So now what happens here is, I have to separate this two integral, I'll be separating. Okay. But integral with the sign will vanish. Let me separate and let me write one more line. Okay. So that line here is, it is integral minus 2 to plus 2, 2 minus modulus of x into cos sx dx. Okay, plus j, I can keep it outside, minus 2 to plus 2, 2 minus modulus of x sine sx dx. What is it I have done? I will explain here. This 2 minus modulus of x, integral of 2 minus modulus of x, if you see, it is common to cos sx and j sin sx, isn't it? First, I am multiplying 2 minus modulus of x cos sx dx. That's what I have written. 2 minus modulus of x sin sx dx. So now, what has it happened here is, the integral with the sign is an odd function. So you can cancel here this value, you can cancel this, it's equal to 0. Otherwise, directly here itself you could have cancelled here, okay, and written it as 0. So I have written just one line for you, okay, this is 0. The integral with the cosine is the cosine integral is an even function. So what does it mean? I can write it as 2 times 0 to 2 minus x. Why do I write x means? If it is a positive, that modulus of x is equal to x. It is cos sx dx. Okay. So now, what is it remaining here? This integration. Okay. So I need the integration of this value. So how to integrate this? I can write it here 2 into, start a bracket, okay, 2 brackets, a pair of a bracket minus the second pair. Okay. If required, we need to go to the third pair, okay, 0 to 2. Let me write the limit. See this? What is it? I'll repeat. 2 minus x power, what is it? The polynomial power? Polynomial power is 1. So what we can do here is, we can write it as 2 minus, start with 2 pairs of brackets, first pair and the second pair. If required, it will go as a third pair, plus, minus, plus. Whatever it is, the first polynomial value, you write it here as it is, okay? Whatever it is, the polynomial value, you write it as it is. Now, inside the integral, if you forget this value, what is remaining, I'll write integral of cos sx dx. Okay, my answer to my question very carefully. Okay, listen to my question very carefully. What is integration of cosine? See here, after 2 minus x, you can forget that. What is integration of cosine is? What is it? Sine sx by s. How do we get this s? Because dx means x coefficient is s. So I can write it here, okay, I can write it here, s into sine sx. Am I clear? So now what is it you can do here is, you can forget the rest of this integral. Whatever it is remaining, this only you can concentrate. What is it remaining? The first bracket differentiation, let me choose the pen now. Okay, so first bracket differentiation, second bracket integration. This is the procedure. Actually learn it like this. What does it mean? We are doing by integration by parts rule. What is the differentiation of 2 minus x? Differentiation of the first bracket is 2 minus x, is differentiation of 2 is 0 and minus x is 1. Integration of sine minus cos sx by s square. See here, what it has changed? Sine changes to minus cos. Okay. First bracket differentiation, second bracket integration. Okay. So this is what I'll get it. So now, wherever I integrated with respect to x, isn't it? First, wherever this is there, x is there, substitute 2. Okay. I'm going to substitute here. This is equal to 2 times, okay, 2 minus 2. See here, 2 minus 2. You know what is 2 minus 2, isn't it? Sine of s2 divided by s. Minus, 3 minus is there, so there will be a minus sign here. Cos of, what is it? Cos of s2 or 2s, okay, s2 or 2s, whichever it is, by s square. Okay, this is first for the upper limit. Okay, now the lower limit. What is the lower limit here is 2 minus 0 is 2 sine 0 divided by s. minus cos 0 divided by s square. Okay, wherever x is there, substitute 0. Okay, 2 minus 2, you will allow me to cancel, which all I can cancel here is 2 minus 2 is 0. 0 multiply anything goes away. Okay, so only what is remaining here, and one more also you can cancel, sine 0. What is sine 0 value? This value is 0. 0 multiply, divide by 0 multiply anything, it is equal to 0. So whatever it is remaining, I'll write it at the next step. Okay, so this is equal to 2 times, what is it we are having? 2 times minus cos 2s divided by s square. This minus plus cos 0 is 1 by s square. Okay, so now it is just the problem is over actually. The first part is over in fact. So it is 2 into 1 minus cos 2s divided by s square. Okay, this is what we are having, 1 minus cos 2s divided by s square. Okay, let me go to the next page now. 1 minus cos 2s divided by s square. So what did we have here is the Fourier transform. We had something called as the Fourier transform of f of x. Fourier transform of f of x is 2 times 1 minus cos 2s by s square. Okay, so I have taken this s squared common. Let me go back to this previous page and I'll show you here. So what is it I have done here is, I have taken s squared common. Okay, the same thing I have written. Okay, here from here to here I have written 1 first. Okay, minus cos 2s. Okay, and this one again, if you notice, what does it mean? 1 minus cos 2a. What is 1 minus cos 2a? It is 2 sine squared a, right? 1 minus cos 2a is sine squared a. If you want, what is it? You can write it here as, it is Fourier transform of f of x is equal to this 2 and this 2 is there. So I can write it as 4 times sine squared s divided by s squared. Just check it. If it is a means 2a. I am having 2s means it's sine squared s. Okay, this is done. So now the first part of the problem is over. Okay, this is the Fourier transform of f of x. Okay, we will name it as number 1, the Fourier transform of f of x. Now let me go back to the problem. The first is find the Fourier transform. Yes, and then if you notice, we need to deduce this integral. Okay, so we need to use the information from the Fourier transform. The question is hence deduce. Okay, it is not this evaluate this integral. First find the Fourier transform of f of x and deduce. Okay, the trick is, what did you find? You found the Fourier transform, right? The equation 1 is the Fourier transform of f of x. So if you have the Fourier transform, to find the integral, you use something called as inverse Fourier transform both sides. I am going to write here, applying inverse Fourier transform both sides. Both sides of equation 1. When we apply the inverse Fourier transform means, literally what is it I am doing here is, I am putting f inverse here. Okay, in this equation, see here I am just putting f inverse. In the equation number 1, I am putting f inverse. So whatever I am having, let me write here f inverse of f of x. Okay, so try to understand, I am just putting f inverse. Okay, So this side also I need to put this f inverse of 4 divided by sine squared s divided by s squared. Am I clear? Okay, this nothing, that step to this step, it's just I have applied the Fourier inverse transform. Okay, so now before applying, let me write it in red color. What is the Fourier inverse? Okay, if you see it, f inverse of f of s, it is equal to 1 by 2 pi integral over minus infinity to plus infinity f of s e power minus j xs ds. Okay, this is the Fourier inverse of f of s, right? So what it tells here is f inverse, whatever it is here, write it inside the integral. This is what it tells, isn't it? 1 by 2 pi, like this. Now you see this part, okay, see this one, what is it we are having? F inverse of, like this we want. So what it happens here is, this is equal to, just I am saying only the right hand side, okay, see this, when I am saying only the right hand side, what is it we will have here is, it implies, okay, so let me write this as equation number 2. See this, equation number 2, okay, let me name it as equation number 2. Okay, so equation number 2. The right hand side of this equation number 2, apply the definition. F inverse means, what do you have? 1 by 2 pi. Okay, see here, F inverse of f of s means, the rule is 1 by 2 pi. Minus infinity to plus infinity. Here if it is f of s, we write f of s. Now what are we having here? This value is, what is it? 4 divided by, it is fully I can write 4 divided by sine squared s divided by s squared e power minus j xs ds. Okay, see if you can understand. Okay, see, this is the Fourier inverse transform definition. If I have the Fourier inverse, see this, the Fourier inverse, if I have this rule, f inverse means 1 by 2 pi integral over minus infinity to plus infinity, whichever it is inside, we have to write it, okay, f of s. Then multiply with e power minus j xs ds. Those who did not understand until now, again you have this thing, you can listen. Let me rub this part and take this. Okay, so in this part, let me take it upstairs. Okay, so here, what is it I have done here? I will just explain it again. From this equation, what is this equation here is? I had f inverse. F inverse of this value means, f inverse means 1 by 2 pi integral over minus infinity to plus infinity. Whatever it is there here, it will come under the integral sign. So 4 by sine squared s by s squared e power minus j xs ds comes from the rule which I showed you, this Fourier transform. Okay, so this is what we have, is equal to, now this side I am concentrating, f inverse of f of x. What do you get by that? F inverse of f of x, like this we are having. So what is it we are having here is, this is equal to f of x. Okay, I hope so you know what is f of x. What is your f of x? Let me go back to the problem. F of x, what is our f of x? Small f of x is, the given function is 2 minus modulus of x. Next line, let me write it. Okay, that value I can write it the next line. I hope so. Now you will allow me to cancel this with this one. So what is it we are going to have here is 2 by pi integral over minus infinity to plus infinity sine squared s divided by s squared, the same thing, e power minus j xs. It is cos xs minus j sine xs ds. is equal to, okay, 2 minus modulus of x less than or equal to 2, 0 mod x more than 2. Okay, this is what we have. How did I get this after equal to mean? F of x, if you see, given in the question. Okay, I am writing it directly. So now what is it we are having? As usual, you can delete something. Which one you can do here is, I hope so, you will allow me to cancel the sine integral, because always the sine integral cancels because of it is an odd function. Okay, so what is remaining here? Let me write the remaining. The remaining here is, and the remaining is only cosine. Okay, so already what do I have? I'll write 2 by pi I'm having. Okay, so the cosine integral, what it will get here is 2 times integral over 0 to infinity. I'm having minus infinity to plus infinity. Okay, so by using the property of even function, so it is sine squared, yes, by using the property of the even function, instead of this minus infinity to plus infinity, I will take only the positive side, 0 to infinity. So 2 times of the positive side, okay, divided by s squared into cos xs ds is equal to the same thing, 2 minus modulus of x less than or equal to 2, 0 mod x more than 2. Okay, this is what we are having. Okay, so like this it goes. So now 2 into 2, 4 by pi. Integral over 0 to infinity. Okay, unnecessary to write this lot of steps. Okay, the last step, I'll come to it. What is it means? What do we require here is, we need to substitute some value. Okay, let me bring it. So why are we doing like this? We want this integral value. Okay, so this integral value we want it. Okay, let me bring it there, Control C. So this is the integral value I wanted. Okay, so here I have this one. If you notice, I have this one. See only the integral. I want this. Okay, means that there is no presence of cosine, isn't it? Cos x's, there is a cos x's should be dissolved. So tell me an x value so that the cos x's will be 1. Okay, I'll repeat whatever it is. Okay, I want this integral. Okay, from here it should become like this. Means that I don't want this cos x. Rest of them I can change it, because sine squared s by s squared, sine squared x by x squared. I don't want cos x. Okay, so by this virtue, what is it you need to do here is, the parameter, the constant of integration. What is constant of integration? Okay, here I can't touch with s, because s is the variable. Okay, I can let some value x equal to. Okay, so what does it mean? This value should be 1. If this value should be 1 means, I need to substitute x equal to 0. This is the only step my students need to know. Let x equal to 0 in the above expression. When x equal to 0, if you notice, what we got here is 2 multiplied 2, it is 4 by pi, integral over 0 to infinity, sine squared s divided by s squared cos 0 into ds. Why cos 0? X is substituting 0. Everywhere you substitute 0. So x equal to 0, in this interval I need to substitute. So x equal to 0, when I substitute, I'll get 2. Okay. So you all know what is cos 0. The cos 0 value, you know it, isn't it? Cos 0 value is 1. And this 4 by pi, when I take past this equal to, what will it happen? 4 by pi will become upside down. It is pi by 4, right? So let me go to the next page and complete this problem. So I'm having, what is it I'm having here is, I'm having integral over 0 to infinity, sine squared s divided by s squared ds is equal to, let me see, what is it we are having? We are having 2, and this 4 by pi, I am taking that side, okay? So it is 2 into 4 by pi. When taken that side, it will become pi by 4. So I can cancel this with this and change it, dummy variable change. Okay, this is not mandatory, 0 to infinity, sine squared x divided by x squared. Instead of s, I am calling it as x, that's it, okay? Dx is equal to, answer is pi by 2. This ends the problem, okay? That's all. We will see in the next one how to proceed.